the trade-offs of looking into that. It's like, okay, how much do we really need that lean forward there? It looks pretty good, but that pickup could still be accomplished by other means that you don't necessarily. I mean, think about it. The bot's not facing straight forward. I mean, it's kind of showing off a little bit. It came over. I'm going to kind of pull it from the side. It could just kind of go straight forward and down. Go ahead and pick it. Not have to have that kind of lean in there by planning it a little bit different. It's one of those things. I think if you ask, you know what, my favorite question is, if there's an actuator you could take away, which one would it be? And if you could add one, which one would it be? You know, it's like one of those that it's like, yeah, get rid of one of those actuators in the torso. It's taking up too much space. But if you could put one back, I'd like to put it in the torso. Like I have that flexibility to be able to get into some of these spaces and do these odd things. So it is one of those things where you have to make that powerful use case of which is the best place to go ahead and put that, and how do you accomplish that? And I think it's also kind of surprising that they decided to go that route, to have that extreme amount of flexibility and make it very human-like in the pelvis and in the abdomen area. It's really good. And then from the elbow down, they have like the worst design I've seen. Well, not the worst, but close to it, as far as the wrist and the hand. So their wrist axes look very much like an industrial bot. The movements are very far back. You know, they're not actually where the wrist would be. It almost becomes like a second elbow in there for some of the movements. And their hand isn't a real hand. It's a 3-finger gripper. I think they have, I have to check. Do they have 2 IP joints in there or not? I have to look a little bit closer at some of it. But I know that their fingers are able to hyperextend, so they can go backwards. So just imagine that they can grab forward, and then they can also like kind of grab backwards if you want. Now, it's not that they're using it to grab back there. It's because they don't actually have a thumb on there. They have 3 parallel fingers that are there. That's it. You know, it's just like that. And so they kind of have this clawing motion, but because they can invert the movement of their fingers, they can turn one of the fingers into the opposable thumb, if you want to think of it that way. Any one of them, maybe 2 of them actually, you know, one becomes like a normal finger, depending on your point of view. So we know that to pick things up, usually you want to have 3 points of contact. You can kind of pick some things up with 2 fingers, like our 2-finger grippers, but it's usually picking up certain kinds of objects. Your general purpose object, you really like to have at least 3 points of contact. Doesn't hurt to have a few more, but it comes out. And this is why, like, a tripod has 3 legs for a reason. It doesn't have 2 legs. It's unstable. It falls over. You put it on 3 legs, and then it's stable because, the 3 points form a plane and geometric reasons. But then again, you have like a lot of people, like a bar stool will have 4 legs. Why does it have 4 legs? Can it get by with 3? It'd be stable. It's like, well, it'd be stable, but it's kind of tippy. So you put the 4th one in there just to make sure it has additional stability. And that's the same thing with your fingers, is that you can get by with 3, but it's nice to have 4 and even the 5th one that's in there. Yeah. So, this was the Happy Halloween video from Figure. And for those of you like me who grew up with a TV series called The Addams Family, you know exactly what this is. This is what they call Thing, which is just a hand that walks or runs around and does all kinds of mischief and everything else. And so for the Halloween, they decided to do this. And it's rather interesting because we get to sort of see how the hand is connected to the arm. But at the same time, we have a glimpse on what the movement of the hand is like. So they may have given away a little bit more secrets here than they're aware of as you look at it really closely. And we've talked about this in previous videos, that if you have something which is single tendon drive, when you close your fingers are going to close down in kind of this clawing strategy, which makes it much harder to be able to grab something. And typically when you grab something, is you want to be able to do a straight finger move. You want to be able to partially close straight finger and then pull on in. And when we see the hand moving along there and doing that walking, I think you'll notice that the fingers are straight when it's walking. And then when it gets to a certain point and goes back, then you can begin to see it curl and go up. And so that tells us that's like, aha, okay. They're able to do a straight finger close right now with this particular hand, whereas I don't think Tesla can, and many of the other bots that are out there we see can't do that are reliable. Mhm. I was hoping you would ask that question. Now, the first thing we can see, it has all the IP joints. So if we're going to do analysis, everyone keeps on going on and on about the Tesla 22-degree freedom hand. The thing is, that's still a prototype. It's not actually been mounted on an arm yet and hasn't been doing any useful work. So if we're going to look at the hands that are out there and really compare apples to apples, the this is a 16 DOF hand versus the 11 DOF hand that Tesla has. Um, this has the additional IP joints in there, which are very important. And it seems like the movement of the thumb can at least do a little bit of opposition. Can't come all the way over to the pinky, but it looks like with the index finger, they can probably do that, or actually within one of these knuckles on the palm. The actuation on there, if you look at it really closely, it looks to me like I'm seeing gears in there. So right up where would be uh, the MCP joint, that's where your fingers are attached to the palm. If you look in there, we can see what definitely looks like gear teeth. And Brett has said in an interview with us that they do not use tendons. And I think he means they don't use tendons anywhere, period, meaning the hands. So, Marwa, how are you doing? It's been a pretty busy week with some updates.
Yeah, it's a lot of updates. A lot of updates. How are you?
Good, good. So last week, the new Atlas came out. It had been kind of quiet a little bit before that, and then a bunch of things came right after with
Yeah, you can't catch up with all this news.
yeah, yeah. And I think the problem was it was Halloween, so everyone was holding back their videos for Halloween. So Boston Dynamics sort of upstaged everyone by going the day before, and then they basically released the same video but with a Halloween costume, and then Figure put something out, Tesla put something out that um, we probably picked up a couple of new data points, and they were fun, interesting videos. But probably the one that we learned the most was the Boston Dynamics one, because that was kind of a long overdue update of the new Atlas robot. And what were your impressions when you saw that? Were you impressed?
To be honest, I think what is interesting for me, the movement of the robot, I think that was quite unique compared to other humanoid that I saw, and I think their approach quite unique. Yeah, I think it's just the movement. I think what struck me the overall movement of the robot.
Yeah, yeah. It was somewhere between being very impressive and human-like in some aspects, but then not quite as fluid where you'd want it to be, and also because it's doing some non-human kind of things, a little bit creepy. So it was really hard to make heads or tails of what was going on. Yeah,
It
but
was
it
unsettling to see the movement. It just
yeah,
like
yeah, it solved a lot of the problems. So, um, the question is, what is it you're trying to do with the humanoid bot? Are you trying to cover all use cases out there, or are you trying to make it very narrow? And it seems to me they're trying to maybe keep it a bit narrow. They finally started developing hands because they never really had hands with the original Atlas bot. So they had more like claws or something like that, very very simple gripper, and they're still going that way. So it's to me they feel like very much like an engineering company that solves engineering problems with engineering solutions, and they're not necessarily trying to make it full humanoid, with the same kind of characteristics, but making some things different. So it's sort of hard to figure out where to start with that that bot, um, because it definitely made a splash last, I think it was April or May when it was announced, and it picked itself up from the floor and turned itself inside out, and everyone was like, "Oh, that's all kind of creepy." And they kept that under wraps, and no one was really expecting that, except that they sort of said that, "Oh, we retired Atlas," and then suddenly, whoop, the next one kind of comes up. Very different because they decided to not use hydraulics, which is what the first one did. And here we see it kind of coming up, and I guess you could lay yourself down on the ground kind of like that with your knees splayed over like that, but that's a really tough move. And then the other things we see here is that being able to twist its torso around, its head around, and everything else. And it looks a little bit like an owl there, and its head's able to move back and forth like an owl. Um, and so you might think, oh, they must have done something really really interesting to design to allow them to do that no one else is able to do. And the thing is, everyone else, a lot of them could do that. It's just a question of deciding what your range of motion is going to be in some of your joints. So when you have a rotary actuator, You can go, on and on, plus or minus infinity if you want. The thing that limits you is that sometimes you have self intersections that are going on, or the fact is you got all this cabling you got to deal with, and you just kind of keep on wrapping it up. So you try to limit the motion, and many of them are limiting it to what the movements would be for a typical human that's sufficient. And Boston Dynamics decided to open the range up a little bit there that allows them to twist it around. So, for instance, I think when I looked at that video, I was looking at what's the head movement? Is it really able to go plus or minus 180? And I think the head might actually be just um n- not quite. It might be like 90 degrees this way, and it comes. Because I always notice it can unwrap its head like in a particular way. It just can't keep spinning around and around and around. But it does give you some interesting possibilities here as far as being able to change direction really quickly without really having to turn the whole body, which is something is that's been a problem with all the other bots. Tesla, Figure, Agility. When they have to do a 180, it's like trying to turn the Titanic. It takes a long time to come around. And that's what's going to kill you in a lot of these kind of pick and place operations. And all of them, there's a certain amount. Oh, I've got to change direction this way. I got to change direction back the way. It's constantly going on. And I don't care how fast your walking speed is. If you're not able to accomplish that, then your cycle time is going to suffer. So that's kind of one way of being able to solve it. And again, if you look at the design of Figure and Optimus, it's possible that they could also pull that same trick in many ways if they just decided that they wanted to open up the range of motion on there. And Boston Dynamics did it right out of the gate, being able to do that on the shoulders, the heads, the torso, and all. It's not too bad a design. Very similar hip design as P&D Robotics, another startup out of China that actually impressed me with their walking speed and their overall approach to the kinematics of their bot, because I felt that they actually came up with a unique design. They clearly studied what everyone else was doing and then improved upon it. And it looks like at the same time, Boston Dynamics came to some similar conclusions on the hip. So you'll notice the actuators in the hip kind of face down a little bit rather than being perfectly horizontal. They form like a little Y, and there's some advantages to it. It allows you to make your hip a bit more compact, kind of bring things in there, lift things up the way you want. The downside is that for your swinging motion, that means your abductors have to kind of counter that swinging motion, or else your legs are going to like swing in and out, swing it out when you're doing that motion if you want to keep them in a plane. And it turns out it's not a big deal because the control system has to either lock them in place anyways, which draws current. And it's just a software solution. So it's like, whoop, could be taken care of really quite easily. So there's really nothing wrong with that. The big thing that they need to work on is Boston Dynamics knows how to walk. Okay. And it looks like this bot can walk pretty fast, but it seems to
compared to
me,
Figure.
yeah, but it seems to me that its feet kind of stomp down. So it's not really doing a heel toe. And you can kind of hear that it seems like, it's a little bit, I was expecting to be a little bit more there, even though its walking speed seems to be probably twice that of a Figure and Optimus at this point. So its walking speed is what you want. Now, this is one of those things I find kind of interesting, is like the whole body movement here. This is what they really nailed, is that it seems all the joints are aware of what the other joints are up to. And it just finds these really nice postures that look very human-like. So when it wants to crouch down, it just seems to figure out what to do, makes it forms sort of the right kind of polygon that you would need to do on the ground to make sure it's very stable when you get down there. And I think it's like this one here. Oh, look how deep that is. I don't think we've seen Optimus do that yet, to be able to go down that deep. So that's
And is it because the rotary motion, like when they go that deep, and is it's
it.
very human-like this
Yeah,
behavior?
yeah. Part of it could be that, they have good range of motion that allows them to get down there. And, I think Optimus and Figure have the range of motion. The question is whether their control system is stable enough to be able to handle that, to make sure it doesn't fall over. So that also shows full body planning. Yeah. My understanding is at this point, Tesla has almost two systems. They've got kind of an end to end from the hip on up, taking care of what the arm and everything else is doing, which is the part that they do telerobotically controlled. And then the walking is all done with kind of traditional heuristics. And it's not clear how much of them sort of talk to each other to say, what's the best strategy? And one of the things that's very nice about that move right there, that posture, it's only really made possible by that torso. So they have a lot of bend in that torso right now. They have 3 degrees of freedom in the torso. So you can see torso is leaning forward a little bit through the torso. Both Figure and Tesla have decided to get rid of that lean forward and actually do it to the hip actuator that you would usually use for walking. So that's how they kind of accomplish it. But that means they would have to do it from there, and they would not quite be able to do that. So that's one of the advantages of having that actuator. Now, Figure One had a very similar torso solution to there, and they took it out of Figure Two, and they took it out for a couple of reasons. One is that torso design there, like a lot of the others that we've seen, eats into the upper torso. Doesn't leave any room for anything else. So it's really about space claim. And they want to put a lot of batteries and everything else in there. And if you're sticking actuators in there and all these others to be able to accomplish that little forward movement, you know, your battery life is going to suffer. And both Tesla and Figure decided they want to have like an over 2 kilowatt hour battery pack. I suspect this is smaller. We've seen a lot of the other bots coming out of China. They have very small battery packs. And a lot of it is because they're trying to put a lot of movement in the torso that may or may not be necessary. And this is what it comes down to when you're doing these designs, like the trade-offs of looking into that. It's like, okay, how much do we really need that lean forward there? It looks pretty good, but that pickup could still be accomplished by other means that you don't necessarily, I mean, think about it. The bot's not facing straight forward. I mean, it's kind of showing off a little bit. It came over, I'm going to kind of pull it from the side. It could just kind of go straight forward and down. Go ahead and pick it, not have to have that kind of lean in there by planning it a little bit different. And
I agree with you. I think
yeah,
that's a question here about copying the nature. And sometimes nature could, as you stated already, doesn't need it.
does
And
it?
you can handle this with different, you don't even need this movement to get this
Yes,
thing. Do you
yes.
think so?
And if it's one of those things. I think if you ask, you know what, my favorite question is, if there's an actuator you could take away, which one would it be? And if you could add one, which one would it be? You know, it's like one of those that it's like, yeah, get rid of one of those actuators in the torso. It's taking up too much space. But you could put one back here. I'd like to put it in the torso. Like I have that flexibility to be able to get into some of these spaces and do these odd things. So it is one of those things where you have to make that powerful use case of which is the best place to go ahead and put that, and how do you accomplish that? The And I think it's also kind of surprising that they decided to go that route, to have that extreme amount of flexibility and make it very human-like in the pelvis and in the abdomen area. It's really good. And then from the elbow down, they have like the worst design I've seen. Well, not the worst, but close to it, as far as the wrist and the hand. So their wrist axes look very much like an industrial bot. The movements are very far back. They're not actually where the wrist would be. It almost becomes like a second elbow in there for some of the movements. And their hand isn't a real hand. It's a 3-finger gripper. I think they have. I had to check. Do they have 2 IP joints in there or not? I have to look a little bit closer. That some of it, but I know that their fingers are able to hyperextend, so they can go backwards. So just imagine that they can grab forward, and then they can also like kind of grab backwards if you want. Now, it's not that they're using it to grab back there. It's because they don't actually have a thumb on there. They have 3 parallel fingers that are there. That's it. It's just like that. And so they kind of have this clawing motion, but because they can invert the movement of their fingers, they can turn one of the fingers into the opposable thumb, if you want to think of it that way. Any one of them. Maybe 2 of them actually, and one becomes like a normal finger, depending on your point of view. So we know that to pick things up, usually you want to have 3 points of contact. You can kind of pick some things up with 2 fingers, like our 2-finger grippers, but it's usually picking up certain kinds of objects. Your general purpose object, you really like to have at least 3 points of contact. Doesn't hurt to have a few more, but it comes out. And this is why, like, a tripod has 3 legs for a reason. It doesn't have 2 legs. It's unstable. It falls over. You put it on 3 legs, and then it's stable because, the 3 points form a plane and geometric reasons. But then again, you have like a lot of people, like a bar stool will have 4 legs. Why does it have 4 legs? They get by with 3, it'd be stable. It's like, well, it'd be stable, but it's kind of tippy. So they put the 4th one in there just to make sure it has additional stability. And that's the same thing with your fingers, is that you can get by with 3, but it's nice to have 4 and even the 5th one that's in there. But it's, again, it's a solution an engineer would come up with. Okay. Speaking as an engineer, you kind of look at it and say, "Oh, it's kind of elegant in some ways," but some people might be saying, "But it might miss the mark." But again, it depends on the use case. Are we trying to fold shirts here? Are we trying to sew fabric or something like that? Or are we trying to pick up industrial objects for use in an industrial environment? And it may be an okay use case, especially because the parent company is an automotive company. And this is an example that probably comes right out of what Hyundai wants to do.
Yeah, maybe the question compared to Figure, because Figure is doing this also with BMW. So
Mhm.
you said that's this Honda already. So I'm not sure if they will deploy that at some point. But if you compare the two humanoid, what do you think about two of them? Where they doing apparently the same use case? Yeah.
Yeah. So, yeah, there's slightly different use cases. What I would say at this point is that both Figure and Boston Dynamics have demonstrated a kind of usable work case better than the Tesla bot has at this point. I know everyone's gonna say, but it's working in the battery factory. It's working kind of slow in there. And I feel the whole thing is like a contrived application when I've been expecting Tesla to be showing us picking up the sheet metal very much like what Figure is doing, because that seems to be the first use case. This is an interesting one. I thought we'd see something more like sheet metal, but it it almost seems contrived, but it's probably not because they talk about that. Yeah, product comes in from the OEM, and the first thing is we got these guys that have to pull them out and put them over in that dolly to be able to go out to the line, and that they don't have any automation for it right now, and it's like it's something that's there, and so someone probably knows it and says, "Hey, can it do this?" And say, "Okay, let's go ahead and check it out." And there's some challenges to it. You can see that sometimes it fits right into the dolly right away. Other times it gets stuck, and then you'll notice it almost gets knocked over, and it tries again. So they've been demonstrating the utility of the automation, autonomous mode, how it works, and the fact that it's making mistakes. Everyone will use it against it like, see, it made a mistake. It's like, yeah, no, 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 no. It's like the thing is error recovery. It's like every computer program has things in it called bugs. Even though computers are supposed to be flawless and stuff like that, everyone's code has bugs in it. And the thing is, how good are you at able to recover from bugs? The same thing is going to happen with the humanoid bots. Is you need to find out how good are they able to recover from mistakes that are going to happen, because not every part's going to be identical. They're not always giving the same place. There's just something's going wrong, and so you can see, it seems to be fairly stable. Didn't fall over. We got a video the next day showing like the Halloween thing. It's a pretty long video. There's no cuts in there. I think it's like 2 minutes or more, where they're not like, oh, let's go and heavily edit this thing to give you the misleading impression that it's like, was able to do all this stuff. Not scripted, unlike the first Boston Dynamics videos, the one that did the backflips and stuff like that. Yeah, they looks like they. I don't know if they had to do multiple takes before they finally get that 2 minute video that worked right, but at some point they're able to do it. And now this one is almost the same, but there is one thing that's a bit different. My understanding is that they may somehow be telling it which slots they would like it to be removed from. So I don't know if it's just going ahead and picking them from a particular slot, and then it sort of knows where it's expected to put them in. So there is some sort of order on how it's supposed to load the dolly. Uh, I was assuming they were just kind of going around and looking for any of the parts that happen to be available. Now, right in here, we get a prankster that's coming in and moves the dolly on Atlas without it noticing. And then when it turns around, of course, it's got to be, whoa, wait a minute. The location is different. And it seemed like it recovered pretty quickly. So, that's pretty good, showing you can have a rather random position of the dolly, and it will go over and then be able to compensate for that. So again, kind of works, looks like it's going to work okay in a real world situation.
Okay. And what could be interesting also can you see here from the manipulation? Do you think anything new here or just
I know. I mean, it's just sort of interesting to see how it does that turnaround there, and it again, it sort of defies your understanding of how the human body is supposed to work when it twists around like that, and you have to run it a couple of times in your head to say, "What did I just see there?" And it's sort of interesting to see how they pull that out, and the part just almost follows like a straight line. That little twist around there is very interesting. So the part itself doesn't have to spin or move. The whole torso or the whole body figures out how to move around there. Now that's like an interesting manipulation. You can see the wrist there. Almost looks like a second elbow there at this point. It's just so far back there um, on the bot. So the manipulation will be different, and everyone wonders how are they going to train this because there isn't a good mapping with a human. So that we're expecting there's some sort of teleoperation, but if the wrist kind of moves a little bit different and you only got 3 fingers and you can turn yourself into a pretzel with this thing like everyone else, how do you train something like that? So they must have devised another way of being able to do it. Maybe they're just doing it purely through simulation and then eventually go out and try it in the real world.
Hmm. Maybe before moving to the physical intelligence, I want to discuss other topics that we already saw this last week compared to Tesla, because you saw that in the We Robot event, especially in the movement. It seemed that you said this is very fast compared to Figure
Much
and
faster,
Tesla. So,
much faster. Yeah.
yeah. And I'm
So
not sure what others are really getting wrong in this like design. Yeah.
that's what we're all trying to figure out is whether they're underpowered or whether it's just a control system issue or what's going on. But it's pretty clear that Atlas has a good walking speed. I don't know how fast it
It
is.
seems natural also. It seems
It,
like a human like a little
yeah,
bit in the
it,
head.
it it does seem natural, but every now and then it seems a little bit rigid. So it doesn't have quite the fluidity that we're used to seeing from the Tesla bot when it came out. But then again, the Tesla bot was really walking slowly. I mean, it was just like doing the real slow sashay down the catwalk kind of thing where you can go ahead and do it. But we haven't seemed to be able to do it at full speed. And Atlas is when it gets moving, it looks natural, and then it kind of is time for the next move, and then it almost like stops. And it's like, oh, I got to go something else, and that's where the jerkiness comes in. Is when there's a sudden change of direction as opposed to just smoothly interpolating between different places. But that's something that they'll iron out in time, I'm sure.
I think this group was at Stanford, I think, and they have a company called Physical Intelligence. I will stop sharing here.
Mhm.
And I want to take your opinion about what they have done so far. I think they have this new, you can see it right now.
Yes, yes, the Pi
They
Zero.
have
Yep.
the, our first, general policy, and they have this, the video here. Yeah. Did you see this video? I don't know if you see it.
Yes, yes, I did, and it's sort of interesting to see what they're doing. So again, it's the same group that had the Aloha and was able to show off the shelf robots with telerobotic control are able to do quite a lot of tasks that you wouldn't expect a robot to be able to do. Especially this is a 6 degree of freedom robot and with really lousy fingers or hands, they're just not very good. Yet when you have a human behind it, and if the human is patient enough, is able to perform quite complex tasks with it. And then of course the big question is like, oh, okay, once we've taught enough of those tasks, how good is it going to be able to do all these things? Now that's kind of impressive to actually be able to fold that many t-shirts. Probably better than I do. I mean, it's like I try every now and then to make them a little bit smoother and perfect, but I can just never really get it to that point. And uh, now to see that autonomously these bots are able to work it out, it's rather amazing. Again, even with like this poor dexterity and on the fingers, they're able to do it. What they are doing is obviously it's very tedious to do all this training with that bot, and I'm not sure how much VR they do. I think the telerobotic setup they have is like pretty much right there, so they're kind of able to lean over and see what's going on. So it's not like they have any special cameras that are helping. So obviously there's cameras that's recording everything, and they're getting enough training data from this that it can run autonomously. In the past, I think they said they were able to do trainings of like between 50 and 100, and then it had like 80% accuracy, which was really pretty good. The main thing is like, well, we want to have a real diverse training set. We want to have lots of stuff, and we don't want to have to just sit there and train basically the same thing again and again and again to get those 50 or 100 examples to it. Is there a better way of doing it? And what they're moving in now with their foundation model is they all you have to do is train just a couple of samples. I think maybe one might be the minimum, but from that they can then bring it into simulation, and the simulation will then generate the other training sets that you would then use for doing the overall training. So it's a way of creating the synthetic data. But the problem has always been in simulation is that the synthetic data that you create there is not quite as good as what you get in the real world. Real world physics is just so much different than the physics we can get inside a simulator. And it looks like from this, they're able to get those training sets that allows them to actually create, the diversity of data. And a lot of it will come down to, I pick up a bottle. I've trained it just to pick up a bottle and put it down somewhere. Now I need to pick up the same bottle in a variety of different locations. And it looks like they've been able to go through and say, oh, that's actually pretty easy for us to be able to do. And the simulation will be very close. So that, whatever it feels like to grab that thing, we'll be able to get that down close enough that the physics we have inside there is not going to mess it up. And then from it, you are able to get the outputs that you would need to drive the joints. So that seems a pretty interesting example of where we are headed. And every time you see these things, it tells you, wow, this really can be done. And whether this is being done inside of Tesla right now or Figure or anywhere else, if they're doing something similar to this, we don't necessarily know. But it does tell us if a bunch of grad students are having this kind of success, imagine what a bunch of professionals with some of the, access to the largest compute in the world are able to do.
I'm just struggling with two things. I think because this is really a company now, so I think they will commercialize this technology. I think I saw a
Mhm.
couple of VC really invested in them. So it doesn't make. I'm not truly sure what to make of that. That's the biggest question for me.
Yeah,
Um,
yeah. And I
it's
think,
just yes. You mentioned a lot of training here. But I am trying to guess what's special is besides this task. But especially they have a lot of investment on their company. Oh, apparently.
I think what it would be is that there are a lot of humanoid startups out there. And the first thing everyone says, like, yeah, but what about their compute? What about their training? What's their AI strategy? What do they have? And, a lot of them would say, oh, they're using NVIDIA or something like that. But at the end of the day, they have to capture a lot of data with their particular bot. So the training set that they're creating here is probably not going to be of any use to anyone that isn't using exactly that kind of bot, because it looks like it's probably an end-to-end kind of solution. But the overall methodology they're using could be of extreme value to someone, and that they might be able to come and say, look, we'll help you with your training. Is like, go ahead, put your bot, we'll come on in here and we'll manage and show you how you can do it and then how you can create the synthetic data so you can now scale up a lot faster. So what this might do is make a lot of these companies that typically wouldn't be able to compete in the AI space to suddenly say, oh, look, there's a service out there we can go ahead and use that will allow us to scale up. So I imagine that might be the approach that they're taking.
Mhm. Anything else interesting about that you want to say, like, or maybe criticism as well?
The Yeah, I think the main thing is that they're doing it over a variety of different arms, so they're able to show it's working for not just one type of arm, but several others. It could be of interest not just to the humanoid bots, but this would be really interesting to see how they could scale this for industrial bots because they are actually using industrial bots in all those examples, even if some are a bit smaller. So it could be something which has more use cases than we can imagine, but um, I don't know enough to be able to say how useful it's going to be or whether actually this is a solution. But I would just say it's encouraging. It's giving us a glimpse into um, how quickly this AI embodiment revolution is moving. There was, the Halloween videos. If not sure if we saw anything. Yeah, yeah, the figure hand, and then also, yeah. So yeah, this was the Happy Halloween video from Figure. And for those of you like me who grew up with a TV series called The Addams Family, you know exactly what this is. This is what they call Thing, which is just a hand that walks or runs around and does all kinds of mischief and everything else. And so for the Halloween, they decided to do this. And it's rather interesting because we get to sort of see how the hand is connected to the arm. But at the same time, we have a glimpse on what the movement of the hand is like. So they may have given away a little bit more secrets here than they're aware of as you look at it really closely. And we've talked about this in previous videos that if you have something which is single tendon drive. When you close your fingers are going to close down in kind of this clawing strategy, which makes it much harder to be able to grab something. And typically when you grab something is you want to be able to do a straight finger move. You want to be able to partially close straight finger and then pull on in. And when we see the hand moving along there and doing that walking, I think you'll notice that the fingers are straight when it's walking. And then when it gets to a certain point and goes back, then you can begin to see it curl and go up. And so that tells us that's like, aha, okay. They're able to do a straight finger close right now with this particular hand, whereas I don't think Tesla can, and many of the other bots that are out there we see can't do that are reliable. Mhm.
You see that this hand already. I don't know. Can you tell what you see here already? Because I think this is quite interesting.
Yeah. Okay. So yes, if you look right where your mouse is right now, that is the
Yeah.
actuator which is going to be for the yawing of the hand. That's like the seventh actuator in the entire chain that's going on there. So we
Is
can
it
see a little bit.
a rotary motor?
It's a
Rotary
rotary
motor?
motor, that's in there, and then the hand gets attached to that, that allows it to go backwards, go basically this way, the yawing movement. And I was looking at really close in there and saying, "Okay, we can also see the pivot points that are in there for the pitching, for being able to go up and down." And at first, when I was looking at it, I say, "Okay, you could, in theory, build the actuator into that pivot as well, that would allow it to go back and forth." And then I'm not sure if you could build the second actuator in there that allows the yawing back and forth. So it's a little bit hard for me to tell there. Typically, the way you'd see it in a robot manipulator is the motor would be the pitching axis that's in there, and then you would have like some other little motor that's attached in there. But I can't quite tell the way the axes are all lining up. Is that whole motor might actually be for the back and forth, and that means, oh, okay, then how are they actuating it going back this way? And it might be that they have some sort of drive mechanism that is connected to the lower part, and then the motor for the pitching is actually back in the forearm. So they have the forearm motor that's going to be doing the pitching, and of course they have another forearm motor in there that actually has the whole forearm move back and forth, which is part of that setup. So that's what I'm trying to tell from there, and it looks like that motor they have is pretty big, and I don't see how you fit two motors in that package. It looks to me like
Yeah.
it's a single motor.
It's
Uh,
it's quite
yeah,
interesting, I think, the design. I feel like there's like gamble movement. Is it like a gamble movement? I don't know.
it's basically it's a roll pitch yaw wrist. So as opposed to like sometimes what they would call a roll pitch roll, where you're going to be right into singularity. So the movement is a biomimicry as far as the kind of movements that we actually have in our hand. So we have primarily a roll this way. We've got the pitching back and forth, and then we have this yawing back and forth. And so it's sort of it obeys the actual movements that you would expect from a human wrist. Where we've seen other bots, other humanoid bots that like they violated, they went right to the industrial robot wrists, which has been the bane of my existence for years because I keep on complaining about it. It's like in some ways a really dumb design because it has this problem called gimbal lock. When your wrist is straight out, you're in what they call the mathematical singularity for it. It's really hard to figure out how you want to move around. And now the human hand mathematically also has a singularity. If you kind of look at it, the thing is you can never get to the singularity because you hit a joint limit before you can get there. Whereas in industrial robots, the singularity is like right in the middle of the range of motion. It's like, why would you do that? Put it at the ends of your range of motion so you don't have to worry about it. So when you're in the middle of your range of motion, you don't have any of these technical issues. So that's a good design there. And again, we can see how the fingers stay nice and straight and they curl when it gets back kind of far enough to be able to do it. You can also see kind of the movement of the thumb. And it's pretty neat that they were able to get that to remain balanced as they went around there. I'm surprised they didn't like fall over and have all these other issues as they drag the thumb.
You
Yeah.
tell me the mechanics here because you told me
Yes.
it's pure mechanical hand. You told me
I
last time.
I was hoping you would ask that question. Now the first thing we can see it has all the IP joints. So if we're going to do analysis, everyone keeps on going on and on about the Tesla 22-degree freedom hand. The thing is, that's still a prototype. It's not actually been mounted on an arm yet and hasn't been doing any useful work. So if we're going to look at the hands that are out there and really compare apples to apples, the this is a 16 DOF hand versus the 11 DOF hand that Tesla has. Um, this has the additional IP joints in there, which are very important. And it seems like the movement of the thumb can at least do a little bit of opposition. Can't come all the way over to the pinky, but it looks like with the index finger, they can probably do that, or actually within one of these knuckles on the palm. The actuation on there, if you look at it really closely, it looks to me like I'm seeing gears in there. So right up where would be uh, the MCP joint, that's where your fingers are attached to the palm. If you look in there, we can see what definitely looks like gear teeth. And Brett has said in an interview with us that they do not use tendons, and I think he means they don't use tendons anywhere. Period. Meaning the hands. So a lot of the other bots use tendons in their hands, even though the rest of the body they don't. 1X, we know famously has got like tendons everywhere. So when Brett was answering that question, I don't think he meant, unlike 1X, we're not using tendons in the main actuators. I think he means like right down to the hand itself. And what this means is with this strategy, without the tendons, um, they can open and close those fingers much better, because when you have a direct drive mechanism, it works in both directions. With a tendon, it doesn't. The only way you can open up a tendon is you need to have a second tendon to be able to pull it back. And that's why the Tesla Bot 22 DOF hand looks like it's going to end up having actually 24 actuators, because for every movement this way, you need a movement to go the opposite direction, which means you're going to need a tendon to be able to open it up. So this choice here allows them to be able to open and close that without having to use springs, direct drive to be able to control it. So the application of the force would be pretty good. The
Just help me understand. This is the gears here,
Yep.
and each of these knuckles here. They do use also gears,
Yeah, yeah, yeah,
or what?
yeah, yeah. So they're using some kind of mechanism. We don't know what the mechanism looks like, but they're probably using some sort of linkages that are able to move those things. And it looks like the movements are synchronized in such a way that the fingers don't curl until the hands kind of get down to a certain position, and then they will go ahead and curl in. It's like right there at that point. So they've come up with a pretty clever design. Now it looks like they only have flexion and extension in the fingers. I don't think they have any abduction. And abduction has some value. Again, kind of going back to the Boston Dynamics hand. The Boston Dynamics hand just has flexion and extension. It definitely doesn't have abduction, and it's sort of designed to do a very simple task of picking something up, putting it down there. So depending upon your application space, you may not need any abduction at all. You'll be fine with having that flexion. The abduction could be useful in other kind of cases. One of them being like being able to, open up a bottle, for example, screwing something on or off. So if you're going to be able to put a bolt onto to something, would be nice to have that, as well as some kind of grasps. So when you're coming down with a circular grasp, it's a lot easier to have the abduction where your fingers kind of spread out to make it easier to pick up something, as opposed to just coming down where the fingers have to remain solidly together the whole way. So there will be reasons for that. There was another hand that came out of China.
I never hear about this company. It's a Chinese company, or
Yeah, yeah, yet again, yeah, Pudu. So another startup.
is it okay? It's a new one.
Yes, yes. So it's a new one. And looking at it, so it has a also an 11-degree freedom hand, which is going to be very similar to the Tesla bot hand, but it looks like they may. I'm trying to figure out why they don't have like a little bit more in the degrees of freedom. So it's just a single IP joint rather than two IP joints that you would normally have in the human hand, very much like the Tesla bot. Um, it looks like they have the extension and on the thumb, as well as I believe the thumb can abduct a little bit. But then looking at it, I think one of their fingers is able, like the index finger, is able to do abduction. So not all of them, but one of them is able to do that. And so I have to try to figure out the count there, because I was expecting to get 12, because it almost looks like it has the same degrees of freedom otherwise there. But at some point, they do show that finger is able to move a little bit. And again, that's sort of a decision that you would want to make of, if you need abduction, do you need to do it on all fingers, or you just do it with one? Now, if we go back there for a second with where they're showing, picking the apple and picking the banana and everything else, you begin to see one of the disadvantages of, again, having something that's tendon driven, and also having like a single IP joint rather than having two in your fingers. And that is, when it closes its hand down, it can't do that straight finger close. So it's like, that's not how you want it. It's like, you're going to break it. Oh, you're going to break the light bulb there. I'm just kind of looking at that. I'm just looking at those fingers coming on down. You want them to be able to curl around. And so that's kind of the problem of closing in that particular way. So that's not the way you want to grip it. So you definitely want to have more IP joints, and you also have the ability to hit a straight move. And again, that's why the figure hand is better than this hand, and also is better than the current Tesla bot hand, because it has the additional movement. It's able to do the straight finger close. And then, of course, is able to open up very easily because it does not have to relax a tendon and use springs or something like that to pop the hand open.
This is two knuckled or three knuckled? Yeah, two.
Yeah. So it's just two knuckles. So it's got the single IP joint on the finger, rather than having two. So those are the interphalangeal joints. Technically, that's what the biomechanics like to call these joints that you have out here on the open finger, and then you have the MCP joint, which is right where your finger attaches to the palm. And we're not seeing this walk, which is rather interesting because
I
it,
think body is not full humanoid. I think they
yeah,
are.
and it may be that this is one of those startups that decided to focus really on the hands and not worry about the mobility. Say, oh, everyone's doing that. We're not going to be able to show that we're any better than anyone else just because we can walk. So they're trying to get ahead of the game because we haven't seen that many Chinese robot companies coming out and demonstrating their hands. There have been a few, and again, it's okay. It's their first hand. They're going to learn a lot by it from it, but that's not the actual solution you want to come up with. You're going to need more degrees of freedom.
And I assume there's nothing interesting in the torso as well. They
Yeah.
just fix
Yeah.
it.
Not too much there. The main thing is that they're showing the sensors that they have, and there are sensors all over the hand. So, not just in the tips, but also in the palm and other.
But just a second. This figure already has tactile sensing already in their
Yes,
hand.
Figure
I'm not
does,
sure.
and I believe this tactile sensors, and Optimus in their second generation did that. So Figure right from the beginning already put them on the tips. And I'm not sure if they have them elsewhere on there, but they definitely have sensors in their fingers. And this brings up another topic is, again, right, towards the end of last week, there's just a bunch of releases, that came out of all kinds of things. And that is that Meta, released this new 360 sensor, which is
Yeah.
quite interesting. So, some researchers at, Meta pretty much announced something they've been working on as far as, tactile sensing and a lot of perception that you're able to now put on any sort of, humanoid hands. Which is rather interesting because it's more than just tactile sensing. It's a lot of different things, including, a built-in camera, and looks like, infrared, maybe smell. It's just like,
It's multimodality.
yeah, the modality is something else. And also the accuracy is something else. It's, as you can see here, they're able to measure, quite a lot of different things. So one is like the force that's going on down there. And, to get an idea as well as, I think it's like the roughness. So they can go ahead and from that, figure that out. So with these different measurements, they can find out, the rigidity of something, or how soft it is, because the amount of force they're having to apply in something, as well as getting a idea of surface texture and many other, modalities that are coming in, that if you get a diverse enough training set, my goodness, you could just, your
Just
sensors could be able to tell whatever it is you're
yeah.
picking.
Yeah, and I need to understand that maybe because I didn't read the paper they have it, but what kind of material did you use like for the table with the sensor? Like
I'm not sure exactly how the sensors work. They did show somewhere in the paper a breakdown of all the different elements that are in there, and certainly the use. The fingertips are lighting up, which is an indicator of some sort that maybe they're using some sort of, light source to help them, get data. But there must be other things that they're also using as far as figuring out the forces, the roughness as they move over. A lot of it is built into the chip itself that's in there. So everything is processed locally. So they have a certain amount of actually onboard AI compute that they're using to help come up with these answers. And as a result, we'll be able to create like reflex actions. So rather than there just being this, oh, we got all this data, we'll just send it up to the motherboard up there to consider what's going on, and then, go ahead and do a react. You can do some, local kinds of things. So they show an example that if you touch something that's kind of sharp, and then, just get this immediate, whoa, if It's not something we expect to move away without even thinking about it. So, it's pretty interesting. It's quite the all-purpose sensor. Looks like it might be one of the best sensors that's out there for sure
I'm not
that
sure. I
I've
think what's interesting, yeah, I'm not quite sure understand what this graph about, but it seemed that the six possibility for the multimodality sensing, the force estimation, which is quite a good small range, very sensitive seems to be,
Yes.
and X-ray recognition and grasp stability, but I'm not quite sure this graph what tells me. I didn't read the paper, so I don't know what to say about it, but I'm not sure what does it mean this figure. Like, yeah,
Yeah,
I'm not sure.
I guess part of it is that if you look at human perception, there's definitely a lot of things we can do. Is we can get an idea of how hard we're pushing on something, and from it, this textile recognition would be an idea of exactly what is the surface that we're touching. So there's like some other information you're getting besides feeling a force. You're feeling something about the roughness of the material you're going on there, and then the grasp stability. Getting an idea is like how firmly do I have that? Does it feel like you just don't have it grabbed correctly and it's gonna slip out of your fingers or not. And then, like, the slip detection is also very important. That's kind of gonna be part of your grasp, stability. When you can feel it sliding through your fingers, well, there's something I need to do perhaps to be able to prevent that. And, these are all important, um, feedback that you need to have with any sort of sensor system, that been kind of surprised that you actually wanna have, like, at least a 5 degree of freedom sensor in many cases to be able to get not only the pressure and, your normal forces, but also the forces that go off in different directions as well as potentially like a twisting motion that you might have on there. So all these are important, components. Being able to figure out, if you're gonna go to the expense of putting a sensor on there, you wanna make sure the sensor gives you a lot of information. This one goes crazy because it even has, like, a built-in camera, so you can kinda see what it is that you're touching, as well as other things, and that will, definitely give, superpowers, like they say, to any humanoid bot that chooses to use this. It looks like it's not something that they're keeping to themselves. It's like, oh, we're opening up for researchers. Anyone that wants to go ahead and buy one of these things.
Actually, they say that they can't commercialize the thing. They are open to proposal. I
Yep.
read this in the blog post.
Yes.
And I think they're partnering with another company. They did the hardware. I think
Hmm.
this is what I understood, right?
I think
Another
so.
company. I don't know.
I
Yeah.
believe so. Yes. So it's quite interesting. From here, just to imagine this. Grabbing that ball, able to make all that estimations of the actual size of the ball, the mass of the ball, and everything else, uh, without just by putting it in between your fingers, and I think to also pretty high accuracy, that they're able to do that. So you can pick something up and go, "Oh, that's spherical, and it weighs exactly this much, and it seems to be pretty hard. Kind of feels like a glassy material, weighs, maybe 10 grams or something like that." Um, and, diameter of like 1 centimeter or something like that. That's a rather interesting capability for your humanoid bot to have, especially like your eyes are closed and you're putting your hands into a bin of stuff and you're trying to find that particular part. And just imagine if something like that's able to go in there and like, oh, okay, I'm looking for a screw or something like that. Ah, that's the one right there. Go ahead and pull it out.
I'm not sure how this will like adapted by. I think what struck me the multimodality, how they fit everything in that space, and the range of the measurement. But I'm not sure how this will be. It changed the scene for the robotic hand that we saw with Figure, for example, and other humanoid robotic companies. If they use tactile sensing, is it needed to have this sensor at the tip of the
I don't
finger?
know if you
That's
need
great.
it to this level. So, um, I don't think any of them are, like, building their own sensors. There are companies out there that provide all sorts of different sensory capability,
And it's
and
very
they're
expensive.
evaluating a lot of them.
Tactile
Yeah,
sensor is very expensive.
and those prices will probably come down as these bots start to scale, but it's still the early days there, and this is gonna be interesting to see how many of them see that this is this what they're looking for, to have the capability? The one thing about that tip is it just there's something about it that doesn't look quite right for, like, a finger. But you'll have to see that able to being able to manipulate real world objects with that kind of very strange fingertip. And that wire coming out, it's like, if that's what you have to have on all your fingers, that's not gonna work. It's gotta be something that's internal.
So it's still early. It's still early stages,
Yep.
maybe.
Still early. Yep.
Do you want to say something? That now?
No, I mean, it's like I just came back from Finland, as some of you may have noticed, and I've got my
I love the T-shirt, by the way.
yeah, this is like, the T-shirt we all got because the company is now 25 years old.
Oh,
So,
wow,
yeah,
congratulations.
so it was like, I think, almost this day, November,
Wow,
1999, see,
wow.
back in the last century, last millennium, it just, a couple weeks left,
How do you feel
and
about that? How do you feel about 25
well,
years with
it feels
company?
strange. I mean, it's really odd when you realize that every time you look at the calendar year, 2025 or 20, it's like that's about the age of the company. So when you get ready to roll over to 25 to 2025, it's like, yep, we're 25 years old. The big thing about that is, of course, 25 is when you start measuring things in centuries. It's like quarter century. Uh, the other thing that's strange is to realize that a lot of the people that were hiring the company, a lot of developers and others, they weren't even born at the time. They were born after the company was formed. So that's kind of interesting that when your company gets that old, that some of the employee weren't around at the beginning.
But anyway, you still have a useful energy. That's what matters,
Mhm,
right?
mhm. Oh yeah, yeah.
The,
And we're thinking, I was like, "Ah, what's the next 25 years going to bring?" It
anyway,
literally feels like
congratulations.
yesterday that we turned 20, and then it's like
Wow.
25 already. Wait a minute, how'd that happen?
Is it scary for you? Is it scary? Because for me, I
No.
feel scared sometimes.
Yeah,
It's just time is run. You
yeah,
feel
yeah, oh, yeah.
scared.
That way,
I don't know why.
the time is moving by pretty quickly, but you get to
Yeah.
look back and see that, man, we accomplished quite a bit in those years. We're pretty proud of a lot of the accomplishments we had, and some of the people we've worked with, and with the meeting some of the new employees that I had met before, and some of the old guys, the old guard. It was it was a fun week, even if it's a little bit colder in Finland than than I'm used to down here in Florida. And as you can tell, I
Anyway,
brought something
welcome back
back
to
from
the home.
Finland. Yeah, I haven't had a cold all year. But
Hopefully next week we catch up something interesting, huh?
yeah, yeah, you never know.